Welcome to the session today. I hope everybody's caffeinated. It's 3:30 on a Wednesday, and we're really excited to be here with you guys today.
Hello everyone, I'm Aditi Gupta, and welcome to this session of Building Connected Vehicles with AWS.
My name is Larry Snow. I'm the worldwide go-to-market lead for IoT and connected vehicle. And Aditi and I both belong to the organization at AWS dedicated to helping customers around the world build interesting, innovative solutions with our IoT services, connected vehicle included. And that's what we'll be covering today. We have a lot of really interesting content we're excited to go over today. So we hope you're caffeinated because we're going to move really fast, and we're going to jump right into it. So here are the topics that we'll cover. First, some of the trends in the automotive industry related to connected vehicle. Second, the way that AWS is helping customers build with our automotive solutions with our services and solutions. Third, ways that customers are building connected vehicle platforms using the AWS services. Next, we'll talk about a new service that we launched at re:Invent last year, AWS IoT Fleetwise. And then finally, we'll finish with a demo, and with any remaining time, some Q&A. So with that, this session begins with a story. And one of the fun things about a session like this is that we get to do some research on the background and history of a certain topic. And we get to introduce pioneers or interesting individuals like this person, Bertha Benz. Now, Bertha is often overshadowed by her husband, Carl, that's known for inventing the first automobile that's pictured here. But Bertha is famous for two things. First, and this is one that I like a lot because I like road trips, Bertha took the very first road trip in an automobile in 1888, traveling 66 miles round trip. And the second thing she's famous for is that while she was on that road trip, she discovered that there was a flaw with the vehicle that her husband had invented. Anybody out there have any guesses what that flaw might be, or even know anything about the history? Any guesses? So, what was that? Steering wheel. No, that would have been a really bad problem, but kind of related, she discovered that there was a critical flaw with the braking system. Now, isn't it...
Put it on purpose, I guess.
Yeah, isn't it interesting that her husband would have made a vehicle that can go, but he overlooked this important feature, which was the brake pads. And so what she had to do was stop and check in with a local shoemaker to craft some brake pads that were applied so that the vehicle could effectively stop so she could continue on her journey. But this is a great example of iteration. And this iteration that started in 1888 has continued and still happens today. Now, over the past, much of the iteration or much of the focus and evolution has been focused on ways to improve the hardware and the mechanical systems of a vehicle. Whereas today, what we're finding is that there has been a shift toward a focus on digital, data, and connectivity as a means to bring these new innovations to the vehicles that all of us get to enjoy today. Now, for any of you out there, first of all, we're not going to bore you with a lot of graphs. It's the only graph in the presentation today. But for any of you out there that are thinking about whether or not to build a connected platform, or whether or not to decide on investing in a connected platform, or whether or not to contribute to a project, this is definitely not something that's going away. So two important data points here. Over the last few years, there have been a fraction of total number of vehicles manufactured that are bundled with connectivity out of the box at the time of manufacturing. Whereas it's projected that by the year 2030, 100% of all vehicles manufactured will include connectivity to the cloud. And that's a radical shift for the automobile industry over just a short period of time. Now, what's interesting to think about is, why are these companies building connectivity into their vehicles? And as we work with customers, we hear lots of different motivations behind what's driving them to add connectivity. But most importantly is that there are kind of four different areas of focus that we hear about that's contributing to these vehicle platforms. First, you have the drive to find operational efficiencies and to reduce costs. Second, ways to attract new customers. Third, ways to increase brand and customer loyalty. And finally, ways to add new revenue streams and subscription services to the vehicles that are sold. And this largely lines up with what we're hearing from analysts in the automotive industry that are talking about mega trends related to automotive and connected mobility platforms. Of the areas or the workloads that customers have talked about, they highlight that electrification is a top driver and this move toward electric vehicles generally. Second, autonomous driving and the ADAS components that are installed in the newly manufactured vehicles. Finally, personalization and subscription services. Now, behind all of these workloads, I think the grand takeaway is that what's enabling these workloads to get created is cloud connectivity. And underpinning that cloud connectivity is data. And it's the data that's connecting OEMs to their vehicles, consumers to their vehicles, and then vehicles to the ecosystem at large. And all of that ultimately, that data especially, is getting funneled into the cloud. And it's that data that's being used to create these new innovative experiences and solutions that are making their way down to the vehicles that we drive today and into the vehicles that we'll experience in the future. So as we think about the automotive industry and as we work with tier ones and tier twos and automotive manufacturers and others in the industry, we help them build workloads wherever they would like to focus. And as we work with automotive customers, we have a range of focus areas, things like product engineering, product manufacturing, supply chain. We also have connected mobility, which is the focus area that we'll kind of dive into deeper today. Before we dive into that, I just want to highlight we have a series of customers that have built with AWS services that are in production today. And I also want to highlight this important bullet point. We have millions of connected cars that are in production, talking to the cloud on a regular basis today. And we're going to talk to you about some of those patterns that those customers have used and how you can start to build your own connected platform, leveraging those well-architected and best practice guides. So with that, Aditi, deep dive on building a connected mobility platform.
Thank you. So we have identified 6 foundational elements for the connected vehicle platform. These are provisioning, connectivity, fleet management, OTA, telemetry, and finally bringing this all together, analytics and insights. Let's take a look at these one at a go. Provisioning. So often the automakers like yourself, they come and ask us, what are the best practices around provisioning? What are the best practices around generating the secure X509 certificates for connecting the vehicle securely to cloud? When should these be generated and when should these be activated? What we tell them is that you can choose to do it whether you want to do it in bulk or you want to do it on real time or in batches, and this will totally depend on what your use case is. Whether you're putting the elements in the supplier chain at the supplier time, or are you doing it at the final assembly time? So the choice is in your hand. Similarly, when we are talking of activation, you could do it on the fly, just in time, or you could do it just before the device activation itself can be done just before you're putting it in the vehicle. There is also a need of customized provisioning workflows, depending on whether you want the provisioning or the status to be least open or least capable, or do you want it more open and more flexible? So think of the time when the vehicle is in plant. You might want to probably give it least privileges at that point of time. And then it goes to a dealer, and then from there it goes to the owner. So going from least to most open requirements, most open privileges. At the same time, as an automaker, you also need to think about security. You need to rotate those certificates as the time passes, and at the same time, there are vehicles which are new in production. So how do you take care of that? These are some of the concerns that constantly come to us. Talking about connectivity. Now for this, I would like to draw your attention to the service AWS IoT Core, which is typically the centerpiece in most of the IoT workloads on AWS. And it brings to us two capabilities mainly, the control plane and the data plane. So control is where we are talking of the control of the devices, the security, scaling, the features like device gateway, device registry, identity service. These bring us the capability to define, catalog your devices, and fully manage them at scale in a secure manner. Next, we talk, it's a step 3 of this cycle, we are talking of the vehicle fleet management. Now, automakers need to manage a fleet of devices, and these management could be on various characteristics. This could be based on geography, on the type or the make of the model of the vehicle itself. This could be based on the software or the components which are installed on that. Or maybe even by owner. There might be other custom parameters. To be able to manage this fleet while provisioning based on different makes, not to forget the different suppliers in the equation. So to get this capability is another thing that customers are looking. And this paves the way for the over-the-air updates. Now again, as automakers, you might want to send the code-signed software bundles to your individual specific vehicle for some reason, or to a fleet of vehicles, again identified by the fleet characteristics which I had just identified. So to be able to send them, that is another capability that customers are looking. Finally, we are talking of the step 5, which is once you've provisioned, once you have connected your vehicle, once you have, in the third step, you have managed the vehicle fleet, sending over-the-air updates, you've enabled all of that. Finally comes the time for collecting the telemetry from these vehicles. And for this, again, we have a new service, which is called the AWS IoT FleetWise. What it helps us to do is to collect, transform, and transfer this vehicle data securely and at scale to cloud. We'll look at this service a little more in depth in a short while, but bringing our focus back to the 5 parameters we just discussed, I want to say that this is something which, being foundational elements, nearly every automaker is looking. And we have made it easy for you to get your journey speed started on cloud by providing to you this AWS Connected Mobility solution, which is a framework with well-architected principles. And you get these services. The architecture for this is given, not really architecture, the block diagram is given here in front of you. So what you are seeing here is, on the left, you see a vehicle. Now this vehicle could be a car, a truck, a bus, or a boat for that matter, any vehicle that is connected. So the vehicle comes with on the edge services. Now AWS provides edge services like AWS IoT SDK, or you could be talking of Greengrass, which bring you the capability to have your machine learning on the edge. You could have your Lambdas, which is the serverless compute on the edge. You have the over-the-air updates capability. You have the security in it. So with these, and there is more. So with these capabilities, it becomes easier for you to speed start your journey. Then in the middle, we have the cloud component itself, which helps to realize different use cases by storing your data, by ingesting your data securely and storing your data in what the data lake is. And finally, on the right side, you see the different mobility applications where we were talking about the insights, where we are talking about the different applications and analytics that you are using. Together, this framework is based on Connected Device Framework, CDF as we call it. So this again brings you these capabilities to answer the 5 questions or 5 points that we had just discussed about making your provisioning, activation, your fleet management, everything easier. And not just that, it also helps you to realize some of the use cases like anomaly detection, driver behavior, your location-based service, whether it is ads or whether it is SOS service. All these are made possible and you get speed started with this. Let's realize one of these use cases and see how it would look like. So what you have in front of you is a reference architecture for a remote control where you would want to interact remotely with your vehicle, which could be for opening the door, closing the door, locking the car, looking at the fuel level, battery level, anything. What you see here is on the top left dotted corner, you will see there is this vehicle communication bridge, which is via green grass, which I just explained is the edge component that we have. So vehicle interacts via green grass to the AWS CMS, the Connected Mobility Solution in cloud. Then on the top right, this data, ingested data, can go to a neutral server or a group of services where it is optionally enhanced by services, external services like maybe weather. And finally, at the bottom, it comes to the mobile for your end-to-end deployment, and you can look at the application in the mobile. Let me request Laurie to take you through some more customers and use cases.
Thanks, Aditi. So as I mentioned previously, there are various customers that are in production today that have connected millions of vehicles to the cloud for a range of use cases. And I'm just going to share a few examples of these. First starts out with BMW. If any of you are fortunate enough to drive a BMW, you've probably experienced what is underlying their cloud connectivity platform using the AWS IoT services. Today, they connect over 12 million vehicles into the cloud, sending terabytes of data in for internal use so that their various organizations and divisions can have access to that data for analytics and other interesting processing. Next is the customer Toyota. They connected their fleet of vehicles to the cloud for a range of use cases. And one in particular is a use case that allows a vehicle owner to use a digital key on their smartphone for interaction to their vehicle via the cloud. And finally, any of you that might be from Germany, maybe you've experienced the Moya rideshare service. Moya is a subsidiary of Volkswagen that has an electric vehicle fleet providing rideshare services in Germany and beyond. All of these vehicles are currently connected to AWS using IoT Core and Greengrass. Greengrass was especially important because while the vehicles were in tunnels or outside of range with no connectivity, the vehicle needed to continue to process the information needed for trip, location, and other details. And Greengrass allows for that offline processing based on what Aditi shared previously about the Greengrass service. So now, once you have a connected vehicle platform in place, the important thing to really think about is how do you intelligently gather and bring that data securely into your cloud environment for processing, which introduces the topic of intelligent data gathering with our AWS IoT FleetWise service. But to start, let's think about the connectivity. First of all, I have already mentioned that 100% of vehicles will be connected by the year 2030. But those vehicles are generating a staggering amount of information, like 37,000 times the amount of information that we collect or use on our phones every day. More importantly, though, by the year 2025, 10 exabytes of vehicle data will be created. And what this means is that it's a massive amount of information that an OEM or a tier one or anyone dealing with this data has to think about. So here's an equation. Each vehicle has roughly 30,000 parts supplied by 1,400 tier one suppliers, not to mention the tier twos and tier threes. Each vehicle has over 200 sensors, and that's growing with modern vehicles today. Times each auto manufacturer, just in the US alone, has roughly 14 models. What that creates is this massive data complexity explosion that anyone dealing with the data has to somehow figure out how to overcome as a pretty significant challenge. So with that, a little bit more of a deep dive.
Right, thanks. Yeah, those were some portions of the data complexity where we are looking at the volume. Let's look at some more complexities when we are start with single vehicle. What kind of complexities come into play? The first and the foremost is the data representation itself. So if you look at it, you have this data which is totally not human readable. This is very machine readable format, but there is all this proprietary protocol which is there. You're looking at a canvas and all the zero and numbers, and if you were to make sense out of it, it's very difficult. Then there are different kind of networks like CAN network, the controlled area network that you have on the automobiles, and there are many such CANs on the vehicle itself. There could be powertrain, there could be chassis, there could be body, which are all sending these data different data at the same time. And we'll see some how the data looks like. But again, that adds to the complexity of how the data itself is coming in non-readable. And the moment you add things like the ADAS, where again the representation, it further compounds the complexity. Now extrapolating it and looking at a fleet of vehicles, if you see, imagine a company which is managing a fleet of vehicles, a rental company maybe, which is all these different kind of vehicles. Maybe there are mini trucks, maybe there are electric vehicles, diesel vehicles, so all different types of vehicles sending different data. They're from different models, different makes, and yet they have to be managed, or you need to implement the same machine learning models or find the similar insights from your fleet in spite of all this varying data that is coming in. So the problem keeps getting compounded. I want to just dive deeper to say that how difficult it is for the data engineers or people who are actually looking at the data. This is a sample of data, how it looks when it is stored as when it is coming as is. So what you're seeing are some of the columns of data where you have the vehicle ID, the timestamp, the actual raw data that is coming in with some brake pressure. And now let's look at some of the entries. If you look at the top two entries, you see the vehicle ID is same. The timestamp is also same. And yet the data is so different. Now why is that and how do we interpret it? This could be happening because it is coming from two different cans. It could be the speed data. One is coming from the powertrain, which is sending you the data from the speed reader, speedometer. The other could be from the chassis, which is actually looking at the wheels, which and the data could be sending from there. So it's basically the same data, just coming from different sources. And we need to have that internal knowledge about the system to interpret it. Let's look at the third column, bottom two rows. Again, there is data, but it is in such different formats, to widely different values. How do we make sense of this? This variation could be happening because maybe one vehicle is in US and it is sending data in PSI. The other is in Europe and sending data in kilopascals. Another one, the column name itself, the fifth column if you see, TGR cell. What does it really mean? As a data engineer, if I were to interpret, how do I really interpret? I really need to know the internals. And this is where, to summarize all the challenges that we have just spoken, we've spoken of the variety of data that is coming in. We have spoken of the volume of data that is coming in. And we have spoken about the timeliness. Timeliness is how do you ensure that you're able to take those decisions? This data is available in real time and in cost-effective manner at the time when you need to take the decision. So again, that is a challenge that we see. Finally, not to forget those data silos with all these different vehicles in variety. This data is not necessarily stored at a center place. This is probably distributed in its own data silos. Again, how do we deal with it? To solve these challenges, this is where our IoT fleet-wise comes into picture. So this is what I was explaining in the step 5 of telemetry, where we are saying that how you are able to easily collect, transform, and transfer vehicle data to the cloud. How it does it is, it easily helps you to standardize your fleet vehicle data. It represents the data in a standard format, what we call as the Vehicle Signal Specification, VSS. So it provides a standard format to represent all the data. It also helps to reduce the cost of data ingestion by doing intelligent filtering at the edge. You might not want to send all the data to the cloud. It does take cost to send data over the cloud. So you might want to do the intelligent filtering on the edge itself and send only the selective data that is needed for whatever machine learning models that you are running or whatever insights the business wants to draw. Don't just mindlessly collect data. Finally, because this data is now intelligently getting transferred in a selective manner, you are now able to take much quicker decisions based on the real-time data that is sent in. Talking a bit more about the VSS, because this forms the basis of how we are standardizing the representation of data and thus solving the downstream problems. What you're seeing here in front of you is how for a vehicle, how some of the information can be represented. So what the aim here is to use VSS, which is your industry standard, making it vendor agnostic and ensuring that you're able to, you're able to map your data, which is in proprietary format, to a more standard human readable format. And each data is identified by a fully qualified name, making it much more easier to make sense. So at the bottom right, you can see there is vehicle.chassis.row1.wheel. Yeah, it's a long name, but at the same time, you get the idea that all you have to do is map your different models, different makes with it all proprietary data, leave it to the proprietary data information experts to say, how is this data mapped? But once it is mapped in your system, all your system in the backend runs in the same way, and you are now free of it. To put it pictorially, what we do is, if you focus on the figure in 4 steps that are given in this. So the first thing the vehicle engineer does is, it models the vehicle, and the vehicle, its sensors, in a signal catalog, all the possible list of signal that can be collected, so it catalogs it. And then it defines the decoding rules by creating a decoder manifest. Now it is the job of the data engineer to see what are the insights that he wants to draw out of this, and what information do I really want to collect now that I know the complete list of signals that can be collected. So the data engineer then creates what we call as a campaign to decide whether he wants to collect data in a time-based manner or based on some condition to say that, okay, if this condition happens, then you collect the data, otherwise just ignore it. It's just regular stuff. Or you could say, send me a data regularly, battery life, maybe just send me data regularly, or heartbeat, maybe every 10 seconds. This is just coming in, and accordingly, you could be saying that, okay, so many devices typically. You would be having your own machine learning models based on these devices. So once these two decisions have been made, the third step is to actually collect this data based on the decisions that were taken. And finally, when you now have the data, is the time to query and find insights and generate insights from these data that you have collected in the cloud. Now, for automakers, you must be well aware of the big data loop. To say that how FleetWise feeds to the big data loop. So you see on the bottom left again, there is this vehicle layer where you have all your components of the vehicle, which is helping and sending data to the AWS IoT. You're ingesting this data. This further feeds to insights or machine learning models or analytics or whatever you're doing. Finally, this goes back again, these advanced learnings and insights, they go back again to IoT, and maybe a new machine learning model, maybe a more advanced machine learning model is now ready to be deployed to the vehicle to take more intelligent decisions now. And thus, the whole cycle continues. That's how the big data loop is fed. I would now pass it on to Laurie to explain some more use cases.
Great. Thanks, Aditi. So just to further illustrate some of the things that Aditi just explained, we're in a vehicle collection schema today. You might be wanting, or you might be monitoring when an airbag has deployed. If you're not doing it in an event-based or a condition-based way, you would be sending a signal into your on-premises location or into your cloud, where every 1 second, the signal or the data reading is the airbag has not deployed, and that would continue endlessly. With an intelligent data gathering process, you could say, when an airbag is deployed, I want to collect this set of data and then send it into the cloud environment, which minimizes that data load and the bandwidth constraints on that connected vehicle. That's just one example of many, and that's what's really great about the FleetWise service. We are not prescriptive about the problems that you want to solve once you have that agent deployed in the vehicle, whether it's not on the automotive gateway or on an ECU, or even in an aftermarket device like a dongle. Once that's deployed and you've created a vehicle model in the cloud and you've created a data collection campaign, the possibilities are limitless related to what kind of problems you want to solve with that data collection campaign active. So these are just a few other examples. We hear customers that are talking about setting up battery monitoring for electric vehicle batteries. We have companies that are thinking about adjusting maps real time based on road conditions. And of course, many companies that are using that data to bring that into their cloud environment for building ML models that are then integrated into their solutions, especially around ADAS. So when we launched the service at reInvent last year, we talked about our partner, Wireless Car, that is currently building with the FleetWise service, and we look forward to what they bring to market, leveraging the FleetWise service. FleetWise will go GA, or general availability, later this summer, and we look forward to sharing more customer stories with you, whether it's tier ones or OEMs or others in the automotive industry. And with that, the moment you've all been waiting for, a demo from Aditi.
Cool, thank you. All right, so I'm going to show you a very quick and simple demo of FleetWise and how the data is generated at the edge and what the different components are. So as a quick view, in case you have not seen the AWS console, this is the console, AWS console, where we have all the different services. So you see here, all the possible services are listed here. Today, I'm going to show you the IoT specific service. I just want to quickly tell that there are different regions in which AWS is available. As you know, it has global infrastructure. Today, I'm just using Frankfurt region just to demonstrate. And it comes with other details as well, where you are able to see the tutorials and AWS Health. You are able to see the billing and all on the main dashboard here. Diving into the service itself. So today, what I'm showing to you is the FleetWise service. So as I go and drill down into the FleetWise service, all I have done is to avoid the loading times. I have tried to open these windows in advance. So what you see here are two models that I have pre-created. If you were to click on them and dive deep, you would see some of the details like the FleetWise training model. You would see details like the signal catalog. You remember the first vehicle engineer, he creates a signal catalog. For demo, we have just taken 2 signals, but if you look at it in real life, it will have probably 300 or even more signals there, which is a complete list of signals. So out of these, then there is a decoder manifest file. The decoder manifest file, if you're aware of your DBC file, you could just upload your DBC file here, and it will draw you don't have to actually map it. You can just, by uploading the DBC file, it can draw some insights from there and understanding those data components. And then I have realized one vehicle using this decoder file and these signals. Now, let's look at the data which is getting generated. So again, here, I'm mocking up a vehicle which is sending the data based on the signals. So I'm collecting two data points here. One is the outside temperature, and the other is the tire pressure. As you can see, we have tried to simulate just very simple, where it's just generating some data. So if I were to, let me just, so what is happening here is, in this particular case, the data is getting stored in a time stream database. That means any data that is coming in will have the timestamp associated with it, and you can do various things with it. So here, if you're seeing, this is just the table details within the database FW training database, but it's just showing you some of the details, like what is the magnetic store retention and for how long we typically keep it. So here I am just trying to go and run the latest data that is getting ingested. The point that I want to show you here is mapping from here, tire RPRs, what is the data that should look like. So let's run this query where I have queried the time stream database to give me the condition-based campaign, where I'm requesting it to collect data based on the condition that I had specified. And then I'm just asking me to give just top 20, the latest 20. Now, if you see, there is an event ID, vehicle ID, which is all generated, which was not originally there. Of course, the campaign name, which is requesting it, but now the measure name is more fully qualified name. There is a vehicle and there is the more qualified understanding, human readable format. The values can also be similarly mapped. In today's, I have just put in as it is, but you can see the values are automatically getting mapped by creating these files. So to give you, for those who are a little bit would like to see what it really looks like, let me just quickly take you through that. So I hope it is readable, but I'll just walk through. So what I have done is, this is a complete signals catalog as a JSON file, which was given to me, all the possible signals that are there. Then for one particular model, we gave more details, like what will the fully qualified name look like. I also put a decoder JSON to say that tire RRPRS will map to the training tire pressure. So when you're talking of different vehicles, different models, you just need this decoder file to say, now map this to this, this to this, and you have it all in the cloud then. Finally, you have your different vehicles that you can realize to say, this is based on this particular model manifest, and this is based on this particular decoder file, and you're good to go. Since I had spoken about the DBC file as well, I want to show you that this is the DBC file I had actually uploaded. So a DBC file which looks something like this, which bit will map to which interface, which fully qualified name of the parameter. That is what it gives to us. So once again, from here, with all the parameters, you are coming and expecting this. I do want to mention that this is something which is, the data is there in your account. AWS does not own this data. What this means is, once we have done this transformation and transferred it in your account where you have made it enabled, the data is fully owned by the customer without any copy on the AWS. So if anybody who's concerned about how and data privacy issues, then this takes care of that. So yeah, with that, I end the demo, and let's move to see. I bet you're now excited that, okay, this looks interesting. Even if you want to just go and try it out and you want to see, okay, Aditi explained about simple CMS. How do I really get started? So I've got a very simple solution for you on how you can go and get started on it today. What you need to do is, we provide to you this reference architecture and open source code in GitHub. So what you could do is, you can deploy it today in your own account. So you have the complete source code there. You can customize your use cases and develop your own use cases, whatever you are thinking. And finally, you can connect your own data that you have in your own data source and get it working. 3 simple steps, up and running. That's all for today. Thank you so much for joining us in this session. And we have some time here remaining, and I and Laurie are happy to take questions if you have any.
So the car can send JSON data or binary data, and that gets translated to JSON and that.
The car will have either a CAN database or maybe sending OBT2 format, whatever it is using. The JSON file is to identify what is the mapping that you need to do. So this is more of a configuration file. That happens on the edge, in the edge client. So remember, we talk about the green grass. The FleetWise has an edge agent. So it happens on the edge in the car. Yeah, so it takes your CAN data or your OBT2 data, and then it does the mapping and sends the data to the cloud in a human readable format.
Any other questions? Okay. Do you want to do that? Repeat the question so they can hear it.
So yeah, the question is, have we integrated it with any user interface, and do we recommend any? We typically refrain from recommending any particular, we leave it to the user and let the user make the choice best as per the use case. But to see, have we done anything? The connected mobility solution does come integrated with a map, with the AWS map services that we have. So you're able to actually track the location of the car and maybe take some more. But again, it does not limit you. This is more of open source code where you can go and try it out and bring your own UI and plug it in with that. It's very flexible. It's in your hands what you want to do.